In our last section of Chapter 1 on equations and inequalities, we're going to look at Section 1.7 on problem solving. These are application problems specifically on the topics of interest and mixture. So math is all about solving problems, and the process that we use when we use variables to represent quantities and then find relationships that involve those variables, that's what we call mathematical modeling. So this section I'm going to make a note that we do mathematical modeling when we use variables to represent unknowns in a word problem, okay? So in the first topic, we said we're going to look at some interest problems, and to do that, we need to understand the simple interest formula. So if a principal of P dollars is borrowed for a period of T years at a per annum, that just means per year, interest rate R, expressed as a decimal, so you change the percent to a decimal, the interest charged, the interest is equal to the principal times the rate times the time. Okay, so this will be a percentage change to a decimal, this will be time in years, and this is money. P is in money. How much are you investing or borrowing? It just depends on either way. So the bank is loaning out money. For them, that's an investment in example 1. So they're going to loan out $9,000 in total. Some of it will go at 12%. That's how much they'll make on some of it, and they'll make 7% on the other part of it. And the interest they received was $900. So the question is, how much did they loan to someone at 12%? Well, how much was that? Okay, so let's think about this. We're going to use our I equals PRT, but in this case, we have we're splitting this money up. So we're going to actually take our 9,000 and put it in 2 separate piles, and the question is how much in each pile. So they tell us that the bank earned an interest. This is the interest received, and remember, the money paid for use of money is interest, right? So you have to pay interest on a loan because you're using someone else's money, right? So interest that they received, we know that number, it's 900. We're going to split in 2 piles. We're going to have a rate for pile 1, and we'll just make that the first rate, 12%, or as a decimal, 0.12. We'll have a rate for our second pile of money, and that's 7%, or 0.07. And then we need a T, but this is 1 year. This is just over 1 year. So T1 and T2 are the same thing. They're just the number 1 year, because T is in years. So here's how it works. The interest the bank got came from the first pile of money times its interest rate times its time, P1 times R1 times T1, plus the second pile. They've split this 9,000 up into 2 piles, times its rate times its time. So we know R's, we know the T's, we know the I. We don't know P1 and P2, but here's what we know about P1 and P2. P1 plus P2 has to be equal to what? Well, they started with 9,000 and put it in 2 piles, so the 2 piles should add to 9,000. So I can get an expression for P2 using P1. P2 would then be equal to what? 9,000 minus P1. Okay, so now I'll plug in everything I have here. I have 900 equals P1 times R1, which is 0.12, times T1, which is 1, plus P2, and I'm not going to use P2, I'm going to use this expression, because I know more about it than just P2. I know that it's 9,000 minus P1. I know my R2 is 0.07, and my T2 is 1. Okay, so now let's do some simplifying here. 900 equals, I'll just make this is 0.12 times 1 times P1, 0.12 times P1. Plus, now I have to distribute the 0.07, of course that's just 1, 0.07 times 1 is 0.07, 0.07 times 9,000, and let's see, I think that comes out to be 630 minus 0.07 times P1, so here times here. Okay, combine like terms. 0.12 P1 minus 0.07 P1 is what? 0.05 P1. Subtract 630 from both sides. 270 equals 0.05 P1, and divide both sides by 0.05, and I get that P1 is equal to 5,400. Now what was P1? Let's look back. P1 had the interest rate of 12%, and they wanted to know how much was loaned at 12%, so we just found it. $5,400 was loaned at 12%. Okay? All right, example 2 is very similar. It has one little extra step, but let's work through this to get a little extra practice. Now, Cindy has $70,000 to invest, and she wants to end up making 9%. Okay, what does that mean? That means she's going to, her I equals PRT, right? She's going to get an interest by investing, let's see what that means. She wants to invest $70,000, so that's P. And she wants to earn 9% or 0.09 per over a year. Okay, so T is 1. And so the question is, how much, that one sentence right there tells us that she wants to earn a certain amount of money. So how much would that be? Well, that comes out to be $6,300. So she's got 70,000 and she wants to earn 9% and get 6,300. But here's the deal. She can invest in a safe government-issued certificate of deposit, but it only pays 8%. To get 9%, she's going to invest as little as possible in this higher paying one, but it's not insured, right? It's riskier. So she doesn't want to put very much in there. She don't want to put it all in there for sure because it's riskier. So she just wants to put just the amount she has to so that she ends up with $6,300. So how much should she put in each? Well, now we know what I is, just like we did here. We know our R1 is going to be the 8%. We know R2 is the 12%. T1 and T2, and again, are equal to 1. Okay? P1 plus P2, what is that equal to? Well, her total is 70,000. So our P2 can be written as in terms of P1 by taking 70,000 minus P1. So here we go. Interest equals P1 R1 T1 plus P2 R2 T2. This is like a mixture problem. You're mixing two piles of money trying to get a particular outcome of interest. All right, 6,300 equals P1 0.08 1 plus P2 70,000 minus P1 times 0.12 times 1. Again, we're just going to simplify, combine like terms. 0.08 P1, 0.12 times 1 is 0.12, and that times 70,000 is 8,400 minus 0.12 P1. Okay, 6,300. 0.08 minus 0.12 is negative 0.04 P1. Don't worry about the negative, it's going to work out. We subtract 8,400 from both sides, we get negative 2,100 over here, negative 0.04 P1 here, and then when I divide by negative, I'll get a positive. So divide both sides by negative 0.04. Can we still see that? Make sure you can still see that. We're going to divide both sides by negative 0.04, and we get that P1 is equal to 52,500. How much in each? So I've got to find P1 and P2. So to find P2, I take 70,000 and subtract the 52,500 and get 17,500. So that's as much as she has to put in the riskier instrument. So the answers are 52,500 in the government, I'll just say government CD, certificate of deposit, and 17,500 in the corporate bond. I'll just put CB. How about that in the CB? Okay.